Let's talk about our sun. Every single second, it's blasting out an absolutely insane amount of energy. I mean, more than all of humanity has used in our entire history. It's just this constant, incredible torrent of power, and almost all of it just radiates away into the emptiness of space.
And that just makes you think, right? Here we are on this tiny little rock, catching the absolute faintest little sliver of all that energy. But what if we could do more? What if we could actually build something to capture not just a piece of it, but all of it?
Okay, let's get into it. Because the solution is just as wild as the question itself. To build something on that kind of scale, a true megastructure, you're going to need a ton of raw materials, like an unbelievable amount. And the best place to get it is by taking a whole planet apart, piece by piece. And this is our target, Mercury. So why Mercury? What makes it the perfect candidate for this colossal job? Well, first off, it's super close to the sun, which means it takes way less energy to get all that material into the right orbit. Second, it's incredibly dense. It's packed with metal, basically a giant cosmic iron ball, perfect for construction. And finally, there's no atmosphere, no life, nobody's going to complain. It's the perfect spare parts department for the solar system.
All right, so how in the world do you actually dismantle a planet? Well, you kick off the biggest deconstruction project in human history. We are talking about a full-on planetary harvest, and it's all done with robotic precision. The whole process is actually designed to be pretty straightforward. You've got swarms of automated miners that cover the surface, digging up and processing all the useful stuff from the crust and the core. Then, all that refined material gets fed into these absolutely enormous railguns. We're talking continent-sized here. And these things just fire payloads of the planet, one after another, into a super precise orbit around the sun. It's a non-stop planetary assembly line, but in reverse. So as Mercury slowly gets smaller and smaller, you get this steady stream of material making a new ring around the sun. Phase 1, the deconstruction, is done. Now, the fun part begins, the construction.
Okay, so here's the genius part. How do you build something that complicated in the vacuum of space? The answer is, you don't. Not really. Each little chunk of Mercury we launched is actually a compressed satellite, folded up like some kind of high-tech origami, packed into a little cube for the trip.
Once it gets to the right spot in orbit, it gets the signal, and it just starts to unfold. All by itself. It goes from this dense little cube into this huge, incredibly complex machine.
And this is what you get when it's all done. It's a massive power station, a solar collector, and even a habitat, all rolled into one. One side is just covered in solar panels, soaking up energy. The other side is basically a giant mirror, which is key. It can bounce useful light to other satellites or even all the way back to planets like Earth. Now, obviously, you don't build something this big overnight. It's a swarm. That's the key concept here. You start with one satellite, then you have 10, then 1,000, then millions. And over decades, as more and more of Mercury gets launched up there and unfolds, the ring just gets denser and denser and denser. And then, after all that work, you hit this unbelievable milestone. The first full ring is complete. I mean, just look at that. A solid band of technology, so vast it's almost impossible to wrap your head around, now circling our star and capturing a huge slice of its energy. And believe it or not, this is just the start. The plan is to add more rings, stacking them up. And you just keep building, ring after ring, until it's done. The sun is now enclosed in this incredible lattice made of billions of these individual orbiting satellites. It's important to remember, this isn't a solid shell. It's a swarm, a dynamic, breathable structure. And with it, humanity has literally captured its star.
So, after all that, disassembling a planet, building a star-sized structure, what was the point? What's the payoff? Well, it's pretty simple. Basically, unlimited energy. Power is just beamed wirelessly anywhere you want in the solar system. Earth becomes a true post-scarcity civilization. Think about it. Problems like climate change? Solved. Terraforming Mars? Trivial. Energy just stops being a problem we even think about. It's just there, like air.
And that, of course, brings us to the final biggest question of all. When you have the power of an entire star at your fingertips, where do you go from there? You stop thinking about just settling other planets. You start thinking about settling other stars. So what does a species become when it can finally truly reach for them? What do we become?